Hello, team. Good evening and welcome to Eastern Academy. And we are into the embedded system programming, week 11 and day 4. And we are discussing about microprocessor buses, why it is required. So we have discussed so many things about how to control the passive devices, then how to control the active devices, then why do you need a bus? So I'll once again list down everything on the board and try to recollect whatever we discussed so far. That will give you a good idea. So what is that? And where you should think logically, where you're supposed to think illogically. There's something. So that's a trick in the whole system. Okay, as we previously discussed, let me put my camera off. So that will give you the lagging. So we discussed things. See, we are very clear. I think we should be very clear on this. By this time, you are not clear. All microprocessors in the world has address line, read, write, and data. That's all. This is what all microprocessors, and they have a power supply, and they have a reset and clock. Clock determines how fast the things are operating, and reset determines to start from the beginning. And we have two more signals called interrupt and interrupt acknowledge to tell you that, hey, I interrupted you, I accepted your interrupt. Next one is DMA. DMA request, DMA acknowledge. Okay, so this is a typical where there can be a small variation. For example, if you take 80, 85 and 80, 86 and on, they will have an extra signal called IO member. That means that they have a set of memory for memory and set of memory for IO. That is the beginning thought, and they were following that. Am I right? That's because they want to have a compatibility with the processor. And if you write a software on 8086, that should work everywhere. That's why they are following the mechanism. There are small variations. For example, if you take 8085, they have put the address and data together called MUX AD bus. This is address, this is data. To separate out, they are given a signal called ALE. Am I right? So these are all small variations. The problem is, if you do not understand the top level, that's very important. The top level is this. This is must for every microprocessor. Clock is a must. If you don't give a clock, this microprocessor is dead. There's no microprocessor which work with the DC. And also, there is something called minimum clock. For example, if you say that my microprocessor is running at 3 megahertz, then you can give minimum of 2 megahertz and maximum of 3.5 megahertz. But of course, this is wrong. This is called overclocked. What is meant by overclocked? Let us say a company called Intel. Intel will test this microprocessor for 4 megahertz. Understand? When they test for 4 megahertz, out of 100 pieces, about 10 pieces may fail. How much 10 pieces may fail? 90 will pass. Am I right? That 90 they will give it to market, telling that will work only at 3 megahertz. See that what they are testing, 4 megahertz, but what they are giving you, 3 megahertz. So what we do, or not me, some hackers, they will take the microprocessor, start giving the clock. If it works up to 4 megahertz, they will still give you as a 4 megahertz, but that is not guaranteed by Intel. Okay, that is the hacker's job. So that means that, for example, if I say that Core i7 works on 4 gigahertz, then the minimum clock may be 2 gigahertz. Maximum could be 4.5. That means that you should not give less than that. So the clock signal is a must in every microprocessor. But the problem is sometimes generating the clock to the high frequency is very tough. So what they do, you give a very small clock, 100 megahertz inside. Outside you do 100 megahertz. But within the IC, we do have something called multiplier. We have not discussed two things. One is what is called clock multiplier and clock divider. We will do this later slowly. Now I'm just introducing small terminology. Clock multiplier. So you will give outside 10 megahertz. Internally, they will generate 4 gigahertz. Think of it. That's all clock multiplier. So this is what the typical system. Okay. Now, from the typical system, we have all the systems used to have a one ROM and a RAM. Okay. This is what they do. They have a ROM and RAM. This is the core. This is the core computing engine. This is a core computing every system. All your computing, whether it's a computer or mobile phone or embedded, they have this thing. ROM, RAM, and this. Plus, after this memory, we call them as a memory. We have IO. We have very simple output. And we have very simple input. That's all. This, I can do the small instruction. As I told you, this case address is 4000. This 4000, 5000 within your memory map somewhere. But that should not belong to any other device. That's a rule. Okay. Now, the trick is if I write a program, char star x. X is equal to 0x 4000. Star x is equal to 0x 01 or 0x 55. That's it. This is nothing. You write a program in a C and you run it on the microprocessor, and that is you save it on the ROM, and the microprocessor execute your code, and then it is giving the address 4000 and write as 1, data is 55, and it will come here 01, 01, 01, 01. So if you connected a motor or a bulb or whatever it is, that will be on. That's it. It is very, very straightforward and very simple, direct. Same way, I write a program, char star x comma y. I say x is equal to 0x 5000. Now I put y is equal to star x. That means that I am reading these inputs and putting it in. You can do anything, whatever possible way your microprocessor, you can do that. How much delay you should give it? What is the maximum minimum delay the microprocessor can do? For example, what is the minimum delay? See here. If I write star x is equal to 0x55, star x is equal to 0x54. See that? I change the 2 bits. 5554. So when I say 55, this become 1, 5 volt. Then I become 54. It becomes 0. Okay, then once again you make 55. Then it becomes high. Now, this is a time. It's a minimum time taken by your processor to give the output. Is it clear? That is, you can easily find out what is the minimum time. If you would like to minimize that more than this, then you have to write this code into the assembly. Okay, I have to write into the assembly. I say move R0, 55. Store R0, 4000. Move R0, 54. Store R0, 4000. See that. First I'm putting 55, then I'm writing 54. This is the fastest you can do that. You cannot do more than that, but still can be done. For example, if you do here, there's an instruction called decrement. Decrement R0. That is faster than move 54 to R0. Okay, we have to know that. We have to know that why decrement. I will discuss this on our 80-85 class from Sunday. Every Sunday class, that you will understand exactly this timing perfectly. You will understand the timing of instructions, how useful it is, how it is so in a C, this is the fastest. And then when you come to assembly, this is the fastest. So you cannot go beyond that. You cannot do beyond this. That's a trick. Okay. So now if you wanted to more than that, then you have to increase the speed of the microprocessor. You have to change the microprocessor itself. Somebody who execute faster and everything. So this is what we discussed, the top level. The second level is, what we discussed was, this we call passive. Okay. And the second one was, we had discussed about another microprocessor, which takes inputs, which gives outputs. Where this guy is having a ROM. That somebody has written a program. What this guy have to do? Not you. This program is not written by you. You have your ROM here. This is your program. This ROM program is written by somebody to do some activity. For example, a dancing display, like that day we saw LCD. When you put the character, how he is displacing A, B, C. How he is displacing Z. This is all method, very easy. You can do it very easily. That's what I'm trying to show you, that I'm sending you the every day that one link which I'm trying to create and do that. Those are all very, very fundamental code. All basics. That works on any microprocessor. Only thing is you have to change the two functions: output, input, and init port. This is because every microcontroller have a different address and different way of initializing. So that is what this. In the case of Arduino, we said that we didn't get the 8-pin port. So if you've seen my code, in the output, I will taken from port B 4 pins and port D 4 pins to make 8 ports. But if you use the same code, if you execute an Arduino Mega, I will do that. Tomorrow I will do the Mega code. The same code. There, the output port is very simple, because in Arduino Mega, I get a port of 8 pins. So please understand, you need to understand input, output, and init port. Whether you use 8051 or ARM or PIC. But my other code, what I have written in setup, I told you setup is nothing but main. In this one, what do you call? Arduino. So don't get confused. Since so that code you can write. So what I'm trying to say is that even though I given a code for Arduino, that code will work as such in 8051 or ARM. People can try it out. Only thing is you have to change the 3. If you change the 3, that code will work directly. If it doesn't work, let me know. Okay, because I did not use the delay. We have given a delay by a loop. We have never given everything by the code. So that should work. So, in a sense, second level, what we discussed was controllers. The controllers have some, one is, the controller has 2 properties. Let us see, understand what controller property. Each controller has some output, dedicated output. it does something. For example, if you take the display controller, this has a HDMI output. That's all. It has only HDMI output, which you can connect the HDMI port to that controller. Understand? And that guy had few registers. That's it. That's it. Now, whatever you want to display in the monitor, whatever you display in the monitor, that through your software, you should write it on the RAM. On the RAM. So for you, the RAM will become a monitor. Then this controller will take it from the RAM and put it on the local and then display it here. That is what the job of the controller. There's a software here which will do the activity. Okay, that is what the that I'll discuss something. We'll do the small ones if possible. We connect all the codes what I have shown in the links. No, what we or something. That it's all simple codes, one microcontroller. Where in future you will use a controller. That LCD is a controller. And then you go to display. Bigger displays, graphical displays. These are called character displays. They're called graphical displays. And then you get into something called GPU. You should learn what is GPU also. It's a very simple concept, but you should learn it. That's called a graphical processing unit. You know that NVIDIA, all these companies are having this GPU. See, the problem is now we have learned the basics. All the other things are all very simple. That is what I'm trying to say. I told you from the day one why I took some time to explain from the electrical to embedded. It's because of these days. Now I want to make it very comfortable. If you're not very comfortable here, electrical to embedded lectures, go back and watch the videos n number of times till you understand. Till you understand. There's no other go. Because all your interview, everything will be based on that, not on this. This will give you motivation. That is fine. But the other one. Now, when you come to the controller, I told you that day itself, when you come to the controller, you lost the control. There's no logic. Because all the logics are done by the person who put it on the controller here. Okay, you cannot have anything with that. So what you have to do here is, you need to do only one thing. That is, read the data sheet and user manual. Try to understand how that guy will work. How that guy work. Okay. If you see most of the companies, there were some managers are very good. Some managers don't do proper management. You know why? Because if an employee comes in, one manager will try to understand what this employee's strength. What this employee's strength. That manager will try to use the strength of the employee. Okay. What will happen? He will call the another employee for another strength. Whereas the manager who does not know anything, doesn't know how to do manage, he will say that, what is this? He never understand this person's strength or weakness. He will give some area where he is weak. He will ask you to push on that. That game may not perform well. Then you will scold him. You will say you are useless. Then at the end of the day, you make him to leave the company. It is a loss for the employee, loss for the management, loss for the company. But whereas the good manager will understand the strength of the manager, employee, and he will be growing the ladder. Hey God, this guy is too good, man. Anybody you give him, he knows how to get the work done. You would have heard this. A good leader of a country will take the country to different. Okay. The same thing here. You understand what the controller is. There is no difference between a good manager and you. Both are same. Both are same. The manager have to understand the strength of the employee. Now you have to understand the strength of the controller, what the controller does. If you don't know what the controller does, start writing the code from day one. Then you don't do that. We have discussed a little bit how we do the thing on the LCD. Okay, when time comes, we'll take up one big controller and do the thing. Okay, fine. Now we discussed two. One is how do I directly control? Then how do I control through controller? These two we have seen. The third one is a very important. Third one is important. I put all my effort for so many years and put it on my controller for a display controller, and that is working with your microprocessor. Let's say Core i7 Gen 2. Suddenly, Intel said we are releasing new generation, Core i7 Gen 3. And our guy, ARM said, ST Micro said, we have an ARM interface. ARM said, hey, we have a different type of interface. So every microprocessor manufacturer have a different clock. Every microprocessor manufacturer have a different clock. It's a Core i7 Gen 1, Gen 2, Core i7 Gen 7, and ARM, for example. But I have only one controller. What people did, hey, don't worry, man. Don't worry. You be yourself. You don't change. You don't change. We will change. But I also will not change. I also will not change. Because this guy clock could be 2 gigahertz. This guy clock could be 4 gigahertz. This guy clock could be different. And this guy could be doing totally the IO differently. Now, what they have done, they have put a bridge. And they made standard. They made standard. Now, this is a committee. There is a committee called Standard Committee. Standard Committee. The Standard Committee will give the set of rules. What are the pins? What is a connector size? For example, you take a USB. Your USB, if you make a cable, if you make a USB pen drive, that should exactly sit with you. That should not be loose, and that should not be tight. It should be perfect. Am I right? Then only things will work. If it is loose, sometimes it will work, sometimes it will not work. You may not buy that. Okay, it should be perfect. So it should be good in mechanical. Next, let us say in USB there are 4 pins. One pin is 5 volt, one pin is ground, one pin is D plus, one pin is D minus. Okay, that you also have to follow that. That means that it should be electrical. Next, electrical. Then I operate with 5 volt. You have to operate with 5 volt. You cannot do 3.3 volts. Then the device will burn up. You should be 5 volt. That is what in electrical they call that as a. As I already told you that we have mentioned that as a DC characteristics. Then we have something called AC characteristics. That means that how fast it can operate. What is the clock? If I have a USB 1.0, what is the clock? USB 2.0, what is the clock? USB 3.0, what is the clock? So every thing, what is the speed and what speed it operates? All the details are called AC characteristics. So I'm trying to, when I'm going into the thing, you should know that why we require bus. Then you will know that understanding the bus will not be very difficult. The moment you see a bus, you will understand so easily now. That is a trick. And third one is the trick. Now, we two are same. Like a plug point, like your plug point. One is phase, one is neutral, one is earth. You have done. You're connected, everything is fine. Now you connect the device which has a plug point, you connect here, and that's working. Because they are all just a very, very passive device. But what you have is active device. Then comes protocol. The protocol is, what should I give him, what he will give me. Okay, in iron box, you don't have it. In fan, you don't have it. You connect it, it will work. But they're all passive device. But the controllers are all active device. Now, when they have an active device, what should I give and what he will give? That is why you have the registers. They will say you that you write this, I will do this. After I complete, I will give you this. That's called protocol. You know, protocol is give and take. Or we also called, are you ready? I ask, are you ready? That guy will say, I am ready. When he is not ready, you are not supposed to give him anything. You will find out whether he is ready or not. These are all the things involved in the thing. But basically, if you write about 2-3 controllers, you will understand. You know one thing. Let me tell you one thing. Let us say you have a controller, display controller, HDMI. You write a software. Your function. If somebody calls you that display something, listen. This is called driver. This is called driver, which goes by the protocol of the controller. So the person who write a driver software, that's what today you're getting it everywhere. Every company, when they recruit you, let us say, if you go to the Qualcomm, if you join Intel, if you join in the Samsung, if you join in Microchip, every company, even a small company, when you join, they will ask you to write the driver. Okay, there'll be 2 people will be there. One person will write the driver, another will write the application. I told you, no. That's what a trick. Driver is a code which will talk to the hardware very closely. To do the code of driver, you have to understand about the hardware. Okay, there are very, very yeah, drivers all API. That's all. Application program interface. That's all. This is called, the driver will contain so many APIs. The driver will contain so many APIs. That means that write, read. That's all both. Hey, you do anything now. You do anything. There are only 2 devices, 2 things. You will do write or read. This is a predominant. You will do write, whether it's a hard disk. You will do write or read. If it's a Ethernet, write or read. You may call transmit, receive. Actually, write means transmit, read means receive. Am I right? This are all the same. So basically, every driver software will have 2 functions main. Okay. The third functions are all few other functions, miscellaneous function. Okay. That we will discuss later. So now the trick here is this standard bus. Or a committees, they will decide and declare what the bus will do. Okay, that's the same thing they came into the UART, which we discussed that day. That is 1 start bit, 8 bits, and a stop bit. But UART before the standard is called RS-232. This is a very cut down notion is UART. The RS-232 will tell you about originally RS-232 is about 25 pin connector. How many pin connector? 25 pin connector. Okay, one side is a male, other side is a female. 25 pins. It goes maximum 50 feet. They will see that how much they say 50 feet, and then that will go up to 9,600 baud initially. Understand? then that will go by minus 12 volt to plus 12 volt. Not 0 and 5. That RS-232. But what happened, as we discussed, that the RS-232 done die because of it came with the bottom, and we don't use them now. Very rarely we use. So finally UART came. The UART takes only 3 pins: RX, TX, and ground. So what happened? They brought down the 9 pin, 25 pin into 9 pin. There's a 9 pin connector. The hardware. These are all standards. These are all standard. So this is a protocol here. Sending one start bit, 8 bits, the stop bit, and the 7th, 8th bit is parity. This is a small protocol. You need to follow that. If you do not understand, that is the trick. Which trick here is the standard bus is defined. I have a microcontroller, and I have another controller, say microprocessor. I connected through I2C. Okay. Ground, STA, SCR. We'll discuss what it is later. Now, how do I debug? That's what I told you, that learn to debug through beginning itself, logic analysis. Learn to understand. If you like to understand these things, the easiest way is logic analysis. There you will see the actual signals. Let's say UART. Let's say UART. TX, RX, C. You will understand exactly what is happening. Oh, start bit, 10 bits, stop bit. You will see it. You will see the 8 bits here. What is the waveform? How much time you are sending? All the things can be seen on this. So, and why this is generally, initial days we don't recommend, because this used to be very expensive. Today you're getting it for 700, 800 rupees, the market. So usually start learning it. That has block. This pins goes to the, like this. You can have 8. You can have 8 pins, another 5 more, and the ground will be connected here. So 8 signals, and this goes to USB to laptop. And a laptop, you have a software. The laptop, you will see that displays. But actually, even a standalone logic analyzers are available. They are quite expensive. So, no. What I'm trying to say is that if you decided to sail, if you decide to build your career on embedded, better have this logic analysis at the earliest. You are going to invest only very small money. If it's going to be big money, I myself will not tell you. Oh, you need to understand about CRO. CRO is possible. That's called DSO. CRO is not possible. CRO is for running signal. It will go. CRO will not store. CRO is a cathode ray tube oscilloscope. That will show what is there now. What is there now? For example, I have a clock for the microprocessor. I have a clock. Then the clock, if I give it to CRO, then it will be coming on the screen, repetitive, because it is coming continuously. So what is coming now is captured on the CRO. Understand? Whereas DSO is digital storage oscilloscope. What that guy will do, that guy will store the signals and put it on the this one thing. But generally, these two are used for analog. These two are used for analog. And they are expensive. Of course, we get the DSO in like USB things. It costs about only some 7,000 rupees. 6000 is a wonderful one. You have a dual channel DSO, and that also has a logical analyzer built in. The DSOs are having, let's say, I have a DSO which has 2 analog channel and about 8 or 16 digital channels that has DSO come logic analyzer. This is available in the market for about 7,000 rupees. Even cheaper available, they are not very standard. 7,000 rupees is a good one. That is next. I don't want to do it now. Now, initially, I spent very little. Okay, 700 rupees one is very good one, which I showed you that. I can send you the link also. No problem. You can buy it from any company, Amazon or anywhere. But don't try to give it more than 5 volt, only 5 volt. That case applies. Break the ground, and the other one is 5 volt. That will be good. So please understand the difference between CRO, DSO, and logical. Logical analyzer will capture only digital. LA is only digital. Okay, whereas your this one, CRO and DSO, both of them are capturing all analog. Okay, and today we don't use CRO. TO is gone. Today we are using only DSO everywhere, because the advantage is when the waveform comes, we capture it, and then we can see play it back later. What happened? That is the advantage in the DSO. So today it is gone. Today we use only, today the moment you get CRO, that means DSO. Okay, today these two become same. Today all the CROs are DSOs. So, but we don't generally use CRO terminology, we use DSO. So digital storage oscilloscope or logic analyzer. And logic analyzer is very cheap, and it can do, you can do wonders. So this is what all about buses. In the buses, there are multiple standards. There are multiple standards. Okay. One is called parallel. One is called serial. And parallel is fast. Serial is slow, because in parallel, I have address lines. Let us say that I have 16 address lines and I have 8 data lines. Okay, if I have 16 wires with the device, I connect 16 wires and 8 wires. Now, what will happen? I will give that, let's say I'm putting the address as 1011 and data is, then I'm giving a read as 1, read as 0, write as 1, because I'm writing. So read 1 bit, write 1 bit. Read 0, write. So if you see that 16 plus 8, how much? 24 plus 2, 26 pins. I have 26 pins, but I can give all of them simultaneously. Now think of the thing. I have only 1 pin and only 1 pin. Okay, only 1 pin, sorry, only 1 pin. Then I have to send first 0, 0, 0, 0, then 1, 1, 1. Then 1, 0, 1, 0, 1. Because I have only 1 switch. I have only 1 bulb. There's only 1 wire. That means that this will be 26 times slower. Which one? That is only for 16-bit address and 8-bit data. If you have think of 32-bit address and 32-bit data, then that will be how many times slower? 64 times. Plus read and write becomes 66 times. If you take a 32-bit address and 64-bit data, think of it, 96 plus 2, 98. This will be roughly 100 times slower. Which one? Your serial. So serial will be very, very slow compared to your parallel. So parallel is faster, serial is slow. Okay. But still, in the world, we use only serial. The parallel used only one time. The parallel used between only microprocessor and memory. And which is the chip, some controllers, some important controllers they do. But afterwards, everything is a serial. Now let us come to the parallel. We will discuss this later, but right now I give you the top level. The parallel, the first famous was VME bus. Even before that, there are so many buses. Famous was VME. It was quite long time. All the industry uses. This is a parallel bus. And then came was ISA. That came on PC. First PC, IBM had a bus called ISA. Okay. That's called Industry Standard Architecture. Okay. Industry Standard Architecture, ISA. Now, then came, there was some other bus called, forget about ISA and all. Then came, there's a bus called PCI, which was very famous, which ruled the market. I'll explain about PCI later. That's very important. Everybody have to understand when it comes to the bus. The derivative of PCI came PCI Express. But PCI is parallel. But PCI Express is serial. Understand? PCI is parallel, PCI Express is series, but PCI Express is faster than PCI. That's the thing. Okay. Then you know that a lot of things called originally it came called IDE interface for the hard disk. Then nowadays it came called SATA. SATA is a serial and IDE is a parallel. So please understand, when there is a parallel bus everywhere, it always contains address lines, then a write and read and data. That's it. This is called about parallel bus. Yeah, PC 104. That's PC 104 is the same as the next division of PCI. The small ones. Yeah, I'll discuss all those things. Because I'm slowly getting into see, the concepts are very trivial concepts. Normally, these are not discussed with freshers. These topics are normally discussed with only few years experienced people. But I'm discussing with you because I wanted to give you some thought behind it. That's the only thing is I'm not trying to force you to, I'm not forcing you, but I'm giving you some thought. Why it came, what it is today, what is the thing about bus? Okay, because there's a meaning for that. Correct. But because of that, do you agree for the speed? Do you compromise for the speed? In parallel, I have so many wires. In series, I have less wires. But because of less wires, are you ready to accept for the speed? There's a trick. Okay. So this is what the trick. We need to be very clear. Yeah, it is serial means just one bit at a time. That's what I wanted to know. That I wanted you to understand the serial and parallel. That is the call. If you understand that in parallel, let us assume that I have a microprocessor, and I have one port, output port. And the output port, I have connected 8 LEDs. Somebody is watching this. Somebody is watching this bulb. I have 8 bulbs. See that? I have 8 bulbs. If I write a program here, that is what I'm repeatedly telling you, that you need to know good at software, because now I'm going to see this is done your connection wise. Okay, you have an address line and you have a combination logic done. and chip select. Then you have a write pin and data pin that goes. Then write and this you are handing, and it goes out. Now I write a program char star x. X is equal to DOX 4000. Star x is equal to 0x55. That's it. Here it gone 0101 0101. So 5 5. Now what happened? Our man will look at, oh, this is glowing, not glowing. You put 0 1 0 1 0 1 0 1. That's all. It one shot. You have written it one shot. He has understood. Now you see that. Unfortunately, now I don't have it. I have only one bulb because he is sitting at long distance. I have only one bulb he is watching. Okay, I have to tell him. So first of all, I cannot send 0. Okay, understand. So what I have done first is I send this first I say A is equal to 0x 55. A is equal to 0x 55. You understand? Okay, now I send for I is equal to 0, I less than 10, I plus plus. So less than 8. Let's take a small sample. I'm doing a sample. Okay. Now I say star x is equal to A. What happened? When I put star x is equal to A, 055 is 0101 0101. But unfortunately, all the pins are not connected. Which one? D1 to D7 are not connected. So this pin only glow. So this guy takes 1. Fine. Now, what will I do here? A is equal to A right shift by 1. See here. Now, when I do A is equal to A right shift, now A becomes what? 0 0 1 0 1 0 1 0. This one gone. This one is gone now because I put right shift. So this 0 has come here. This is all right shift. Now, when I do that, when I go back, I put x is equal to star x is equal to A. Then this 0 goes here. So bulb is going to be off. So our man will write 0. Previously 1, now 0. Now, when he come back, he will do once again right shift, that bit. So what happened? I do this loop how many times? 8 times. Understood? So previously I written it one line. Star A is equal to, see that? Star X is equal to 55. I wrote it at one shot. Now, when you do serially, I take so much of time, the loop. This is called serial transmission, nothing more than that. This is what serial transmission. But we optimize this in a chip to make it faster. That when a time comes, I'll tell. Right now, don't get confused. Right now, what can you understand about functionality? Don't try to confuse too many things. Right now, understand functionality. Don't try to go about performance. So this is a trick, but advantage is, let us say this guy is sitting about after few hundred meters. I need only one cable, man. If I do a 8-bit, 8 bulb, I need to have 8 wires I have to run. People will say that it will be slow, man. Run only 1 wire. That is what today. There are a lot more reasons. As somebody has asked, what is the thing? Why we are preferring serial? Because USB, SATA, and this one. SATA is serial ATA. Then ATA is nothing but IDE. That's I'll explain later. Universal serial bus, PCI Express. The Express is nothing but serial. Ethernet. These are all outside. And within the system, you have I2C, SPI. And outside is once again this one, UART. We use that. But only thing is, from the microprocessor to memory, especially RAM, they make it very fast. You know one thing, in your PC, you have a ROM that you call BIOS, that is connected to SPI. Think of it. It is connected to SPI. But that's very tricky. Okay. So it's very slow series bus. But what they do here is the moment you power on, this microprocessor takes the code from ROM and copy the entire code of ROM into RAM. Then the ROM is useless. Then he will execute everything from the RAM. The ROM is used only for in the beginning to hold the data. Otherwise, RAM will not have the proper data. Okay. Now we have explained that why we need standard bus. That is, I can connect multiple controllers or devices based on standard bus. For example, I make a chip with UART. I make a chip with I2C. I make a chip with SPI. I make a chip with CAN. Now this side, you can have n number of controllers. I don't mind whether you have a Intel, Atmel, ARM. So for let us take one of the very famous chip is RTC. That's a real-time clock. That means that you give a battery here with the RTC. You give a battery. Okay. Also, you give a crystal here. Enough. You won't set the time there. Then even you switch off the machine, that RTC will be keep on counting. That's called real-time clock. Okay, that chip are quite famous. These are some number is I think DS7204. I think that I don't remember. That's all you have a net to search what is RTC chip. That's enough. For example, if you take the pin, that pin will be a very small chip, maybe 8-pin chip. 2 pins will be connected to battery. One is power supply, and then this is backup battery. This is a backup battery. When power is given, the battery will not use it. Then you have I2C. This one. STA, SCM. That's it. Okay, now this is what the advantage of your standard buses. Then we have to know that when you will use I2C, when you will use SPI, when you will use CAN, when you will use what? That's a trick. So these are all the points. All of them are serial bus. First of all, understand all of them are serial. And all of them are standard. Then you have to know, you have to understand go by the standard, what the standard says, what the standard committee says. Okay. Then when you will use what? When you will use UART, when you will use I2C, when you will use SPI. Okay. That there's a small trick here, which I have to tell you only one thing. In parallel and serial, there are two methods. One is there can be only one master. Okay, others are slaves. They only accept. Okay, they are only slaves. And in both it's that. Whereas in some buses, we have here also master. Okay. And there'll be somebody in between sitting called arbiter. Understand who is that? Arbiter. There is a signal will come from both the people called request. You can have any number of people. People will give you what request. let's say 5 people are there, you 5 are raising their hand. Then the arbiter will decide, hey, Balaji, you speak. Ganesh, you speak. Here, that's called signal. Okay. The arbiter will get the signals and he will allow you can speak. Now, once he becomes the master, okay, he can transfer data from any memory to any memory, anything can be done. He becomes the master of the bus. Okay. We need to understand that so the top level, we need to understand. One is, this is I think from summaries. The summary is very important. On the host, we have a host bus, absolutely called non-standard. Non-standard, but high performance. That is advantage. That is the advantage of the host bus. All the host buses you cannot connect. They are waste because they connect only the memories and everything. Now there will be a bridge. From there you will get the buses. That will be another standard bus. It will be another standard high speed, let's say PCI Express or PCI. They're all high speed, but not as speed as this. There will be a standard bus. That means that I have another PCI. Then from the PCI, I will get to USB, UART, or what do you call it? SPI. I2C, everything. They are slow. These are very high speed. Okay. These are all, see, all these things came because of only one technology, man. All these things are possible, and today you have, see, the problem is plenty. You have a plenty of jobs, as I told you, because every day some new development and new progress and everything. Now, the trick here is, when you know this, is very important. Are you going to know these things after 4 or 5 years of experience, or starting itself, you know that and proceed with it? But if you know all these things also, the first priority is C programming. Please understand. You know everything, and if you don't know C programming, nobody will get you into the company. I'm assuming that I'm discussing all these terminologies, everything to you, because coming days I'm going to discuss more on this line. That is why I've given the top level thoughts here. What are these things? Okay, how? Because you understand these things, you will understand computer architecture, mobile phone architecture, because the word is coming everywhere nowadays, SOC. We have to understand all those things. If you want to understand all those things, you cannot avoid this. So I am giving a very top level picture. Don't worry about any microcontroller. They have whatever the bus, they have it. Okay, then we have to worry about this. How do I write into the controller? If you say that I am good at PCI Express driver, I know PCI Express. That's all. You get into this is used in the very top level MNC companies. This is used by the very top level MNC companies. That's all. You get in. You get in. Okay. They wanted somebody who knows the word. Am I right? If you say I know, then they will ask you a few doubts. If you explain to them that, you get in. And the beauty is you can write the drivers, all these things at your home itself. Nothing big. They are not big enough. Next is this next level. You say that I know I2C, SPI, USB, and UART, how they are working. You write your resume. You know these things, and you write few things extra. I made I2C this drivers. Never use the word software. Write the same word as a driver. I've written I2C driver for RTC from scratch. From scratch, the word is very important. I didn't use the libraries that you have to convey them from scratch. Okay. Understand? This is the first thing. Then after this, but as I told you repeatedly, these are all valued only after the C programming. So right now you do this, master this, what I'm saying. But why I'm explaining these things are all, we will slowly touch upon, because you have done a embedded system programming course. You should know what are all these things, what everything is done, and how to use the I2C controller, how to do the things. This is all very, very, I'll give you a few samples also. That is, we have I was sending you the code from some simulation. That itself, I'll send you that. You can use it on a live board also. Doesn't matter. Both the codes, that's why I'm accepting. When I wrote the code, I found out they are same. The same way it is working on the regular board also. There's no change. For me, you have to understand the technologies. Okay. So please understand this bus, how the buses goes. Okay. That's a trick. There's nothing. One is very high speed. One is very high speed. That is host bus. Very high speed. Ultimate. Nobody can be faster than this. This guy is the fastest. Then we have a bridge. Reduce it to high speed. High speed, but standard bus. Like PCI or other PCI Express or whatever. There are so many other buses. Now, from there, you have another bridge, or we can call controllers or whatever it is. We have so many other buses. USB, I2C, SPI, and the CAN, Ethernet. They're all easy. All of them are same. If you understand one, you understand everything. Okay, there's nothing else. The moment you go to serial and all protocol, and you should know what do you want. That's the only thing. Okay, you know to go to every hotel, everywhere you go, you know what do you want. That's the only thing. This is the top level. Now, how do we measure this things is how many bytes, how many bits normally per second I transfer, or how many, if it's a parallel bus, we call about in bytes. That is called bandwidth. That tells you that I can do maximum only this much. I cannot do more than that. I cannot do more than that. That is what your bandwidth says. Let us say I have a 9,600 baud rate. That means I can send only 9,600 bits per second. Am I right? That is what the maximum bits per second I can transmit, ones and zeros. We will discuss about later called what is throughput. There are two terminologies. One is called bandwidth. Bandwidth is thing what is possible, and throughput is the one what we achieve it. Okay, for example, if you put the 9,600 bits, there'll be a one bit will be wasted by start bit, and one will be wasted by stop bit. You transmit only 8 bits. One will be was parity. So you have only 7 bits you send. So that's only the thing. So I think I've given a enough intro for what is the buses, what is meant by standard bus, why we need standard bus. If you have any doubt, ask me now. That's very important now. Some of them who are not up to the speed may not understand this, but don't worry. You will get to know that when you keep on working on it. I see we don't have any limit at all. If you say that you are not, think you can come back to the next batch lectures. There's nothing wrong. We don't stop that. Oh, this is done, man. You cannot do anything. No. Till you understand, you can be with us. No issues at all. You have a lot of problem, man. Don't mistake. Everybody have a lot of issues and no time for you at all to grasp. Yeah, I will tell you that. Auto board detecting. Yeah, correct. They have a clock, not exactly clock divider. They have something called PLLs. They have something called PLL, DPLL, digital PLL. I'll discuss about what is. Yeah, I will explain to you next week. That's why today, this week, I've given a top level discussion about SPY and I2C everything. Next week onwards, we will discuss about what is SPY, I2C everything. I2C is a reliable bus. SPY is not reliable bus. So wherever you want reliable things are wanted, you have to use SPY, I2C, not SPY. SPY is only for high-speed data transfer, not for reliable data transfer. Because I2C have acknowledgement everything, so which is not there with SPY. Okay, now I told yesterday that there's one thing I'll discuss today. That's fine. Somebody has asked about that. I'll do that also. It's called auto bound. Today you set at one place. It's quite simple. You set at one place 9,600 and you transmit 55. Sorry, AA. You send AA. What will happen? Think of it. You are sending a AA. A means 10, 10, 10, 10. Am I right? This is what A. Then you have a start bit, you have a stop bit. I send few AAs. I say AA, 4 AAs. So I'll send the start bit, then I'll send the 0 data, then 1. Am I right? You understand that? See, I'm sending 0, 1, 0, 1, 0, 1, 0, 1, stop, then start, then 0, 1, 0, 1. Now what happened? This is the interval of a bound. Am I right? Okay. Now our man who receives this data, the clock, he measures the distance between these two. And he will measure the distance between these two, everything for about 10 pulses. Then add all of them and do the average. Then you will get the bound right. Even there's a small deviation also. Since I take the average, I don't take only one. I take the average. It'll accumulate. This is what they do with the auto bounding. So I transmit AA data. So when I transmit AA, it became automatically becoming a clock. Actually, if you understood some, I'll discuss this later. Maybe you understood something called in Ethernet. I don't know how many of you have studied Ethernet. And the packet, there's something called preamble. Okay, the preamble is actually 56 bits of data, which is nothing but a clock. That is what it makes both the sides become synchronized. Okay, the same thing here. This preamble, here also this is called preamble. I sent her some data, which is exactly like a clock. I don't send here 1 0 0 0 0 0 1. Then it's gone. It's not clock. I will send always 1 0 1 0 1 0 1 0. That's it. Then it becomes a clock. So I cannot send clock, but I'm sending data itself as clock. Okay. It'll be very nice if people start understanding that. It'll, if you get into the more insight, then you will know that. So any other doubts? Basically, I don't wanted to start this. I wanted to have a. Not every time. This is only while starting. While not every time. While only starting. We don't send every time. Yeah. See, the clocks are configured at the beginning. So when the first time when the system transmit, he will send the clock and make sure that it is thing. Whenever you change the clock, he will do that and do the auto direction. Not every time. That they have some protocol. These are all how the software is handled. Is you have to get to know every company's software will be different. There's nothing. See, very unfortunately today, there's nothing called very standard in software. Everybody will like so many standard in the hardware, not much in the software side. Every company will do the thing. Otherwise, for example, think of it. If every company would have the same assembly code, things would have been better today. You have so many assembly language and so many machine code and everything. Yeah, that's it. Start is always high and stop is low. No, same thing we'll discuss. Even your this guy is having a SPI is having a start stop. Your I2C is having a start and stop. We will discuss about that. What is the advantage of synchronization over asynchronous? Everything we'll discuss thoroughly. We have to know that this all. See, I told you now, which are all the questions generally we ask in the interviews. I will put it here, and whenever you have a time, you watch the videos. That's what I can do. I cannot make you to understand with over the class within about 1 or 2 hours. That's why I'm telling you that when you connect 2 microcontrollers and you do the UART, that will be very good. For example, you take Arduino and that you use the standard RxTX, and you take 8051 and write the code, or you take 8051, use the Arduino and do the thing. Then you will understand that how one should be standard, one should be non-standard. That I once again write it down. See, one should be standard, one should be non-standard. Then you will understand it. That's a trick. If you do both non-standard, then you don't know who is wrong, who is right. Always try to. But it is very tough to do with the top level. I told you now, these 3 are very easy. SPI, I2C, and the UART, they are very easy. So try to learn it as much as possible. But that is not possible with your CAN and other ones. They are all different way of working. It's easy. You can simulate all these things in the software. We will discuss one by one next week. We'll take one I2C. I'll explain to you that very thoroughly what is I2C and everything. How do you write as functions and everything? Oh, I don't know. I have not taken higher studies on embedded. Embedded is full of practice. Embedded is full of practice. If you learn, do it, practice, and go on higher studies, and then whatever they teach you, you do excel, you will get a job. Then go to job and do more. See, if you want to go to embedded any country, anywhere, only rule of the game is like this. After engineering, normally take 1 year off. Don't go to any job. Don't go to any job. And master embedded and write gate. So try to get into either IITs or NITs, or you can go to US for MS, US or German or UK, wherever Western it is. But if you don't do this mastering embedded and go there, these companies, places, it is waste. You don't have a time to learn everything. These are all skill. But if you learn and go there, you will do wonders. You will get good recommendation and you will land on a best company. Best company. This is what everybody is doing a mistake. After BE, you should never take masters immediately nowadays. You should spend 1 year for this. And during the college, never prepare for GATE. Always try to score maximum CGPA. During the college, store CGPA and then take 1 year off and prepare for GATE. Then get into the GATE. This is the rough methodology, and because this was not there a few years back. Now, because of GATE competition, this is what I generally prefer. If you could able to offer to take a year off, do this. You will learn much more than joining a company. This is much more than joining a company. One year is a very good time. You can really master embedded. 1 year is a very good time. Correct. That is what correct. What Abu Dahir is telling is a perfect. You should learn documentation. Learn every day. Every day. This all nobody told us. And those days everything was very expensive. I told you, salary was 1,580. My PC was 1 lakh. Think of it. How much I will save every month? 100 rupees. At the end of 1,580 rupees, I saved a small PC with 8 megahertz CPU. Think of it. 8-bit, 8088 CPU with 640k kilo RAM and 20 MB hard disk. Think of it. 8 megahertz CPU, 640k RAM, 20 MB hard disk with a black and white monitor. Okay, with a black and white monitor. Okay. Oh, fantastic. That's correct. Somebody said, what did we find? So we found the right method. Thanks. Okay. So now it's fine. Okay, now it will be okay. That thing is a one. This lacks, we found out the reason at last. Now, this is what I paid about 1 lakh. See about, if I save about 100 rupees a month, how many months I have to save? But today, you have a logic analyzer, you have a board, you have a simulation, you have everything, man. I don't know what stops you today. I do not understand. Let me be honest. I do not understand what stops you today. You know one thing, what stops you? Competition. You worry about the competition. Second thing is, perfect. Somebody has given a very good direction. I get. You know, you heard the story, na? I read it recently. There's one story came. There's a beautiful story. The king asked the minister, which job everybody knows, most of the people job. He said that most of the people in your, most of the citizens in your country are doctors. He said, hey God, he said that only few doctors, man. Then he said, no, sir, no, king, no excellency, everybody is a doctor. Then he said that, he asked, can you prove it? He said, fine, I'll do it sometime. So then he requested one of his employees, next day put a small tie plaster in the head and walk to the this one kingdom. Then he was coming. Then he came to the thing palace and met the king. King asked, hey, what happened to you? He said that there's a small headache. He said, you take this pepper rasam and this things. Then he said that, then why you, with that headache, why you came to palace? No, excellency, only your minister asked me to come here. Then he asked why. When he was coming, he asked me to tell you that I met 100 people outside. 86 people gave me the advice of what medicine I should take. When I entered into the complex, I met 20 employees in our palace. Out of that, 18 people told me that what medicine I should take. When I met you, you also gave me a medicine. So I get now this many medicines. So that means that everybody is a doctor. The same way, today, you have so much direction from the people in the net and everywhere. You are totally confused, man. You are totally confused. Let me be honest. We did, somebody has given us so perfect. The direction, it's very good. But the beauty is, don't confuse. You have all the direction. I told you now, this is the best way that the Stanford professor has told. Yeah, these are all only them, man. The Birbal Akbar, and I read all the stories, man. I'm the love. I read every even today. Birbal Akbar and Tenali Rama, and then Mullah Nasruddin. You know one thing. You would have heard another beautiful story. That is what exactly we do. Mullah Nasruddin said one day, Mullah was searching for something here. Then when he was searching, all the people have joined him. He told him that I lost my ring. Then everybody was searching. So many people. Then one new guy came. The new guy asked Mullah, where you lost it? I can also help you. He said, I lost that. Then you lost there. Why are you searching here? Mullah said, there is no light there. Only light is here. So that's why we are doing it. We are searching something where what we know. But we don't search what is required by the industry. Who told you in the 4 years of BE what is required by the industry? It is told by your professors and lecturers. Understood? Or somebody in the higher education department who made the syllabus. We industry people have tried to change the syllabus. We met the vice chancellors. We met the syllabus committees everywhere. Nobody refused to change the syllabus. Understood the problem now? You search somewhere and you lost somewhere. Please understand what is the requirement and go towards the direction. That is what we'll say now. Let us say you are in a seashore. You have a small island somewhere. But unfortunately, when you stand here, you cannot see the island. It is about 1 kilometer. But it is somewhere here, anywhere. See that? It is 1 kilometer anywhere here. You don't know. How do you go to the island? Will you swim and come back? That is not right. So, better climb the lighthouse. Tall building. From there, watch. Oh, it is here. Then, and that direction you swim. Somebody said the very small word direction that has so many meanings, man. That has so. This is called time investment. What you are doing now, I'll tell you what you are doing. First, you are going on this direction. Let me go with VLSI. And somebody said, no, learn Java, man. You come back and learn Java. Somebody said, Java is best, man. Learn the web application. You do web. Somebody said, no, man. You learn C programming. And somebody said, go to embedded. But we don't understand one thing. You know one thing? Everywhere, there's a job opportunity. But after you reach here, what we do is, we just go there and come back. We don't reach the town. That is possible only if you concentrate on one thing. If you take VLSI, you master VLSI. Don't worry about job. Don't worry about job. Master VLSI. Today, there were market full of opportunity for Java. Market full of opportunity for web application. Market full of opportunity for C++ and embedded VLSI. We have opportunity everywhere. Why you are not getting a job? That is because you don't have a direction. Direction. The 4 years, so wonderful period. So wonderful period. You are losing it without direction. That's a trick. Take one. Take one. Master, don't worry about the line. Don't worry about that. Only after you cross this bar, you have the job. You will see visible the big job. But you see from here itself, you come back and try. This is not good. See, your robotics, your AI, machine learning. See, the thing is, understand one thing. Things are changed like this. Mathematics. Things are like this. Mathematics on paper. From there it came physics. Physical. X. From physics, it came so many branches. Yesterday I was talking to somebody. He said that, hey, Balaji, plenty of jobs is there in the mechanical field, man. That's it. That field, what happened now? Everybody is going to be, all the 99% of the Indians are going to be AI engineers. Think of it, please. You have come here. We are discussing embedded. Spend some time. Till you achieve embedded, don't. I myself be teaching you. I'm giving you the idea about other things, analog. I'm going to have a session called VLSI later. Introduction to VLSI. What is VLSI? You should know that. As an embedded guy, you should know that. Then what is board design? We'll discuss. Okay, we'll discuss all those things. I'm not saying no. But the problem is your focus has to be embedded. I know that a lot of people here in our group itself, even though I'm every day I'm telling, still they don't touch C programming. They thought they can learn it later. The later will never come. This is a skill. Somebody is doing wonderful. Few people have done really wonderful job. They have completed 55 programs very nicely. They gone to another one, assembler. They gone to simulator. Few people. Okay. Those groups will become climb the ladder very fast. Any company will give them the job. They will beg for these engineers. But people don't understand the power of the programming. What I'm saying that, do your work, your skill. Do your skill. I will do my work. I will give you all the informations. What is required by the industry, from electrical to embedded, everything. We'll start practicing. But whatever it is, man, you have a time only this much. This much time, you can learn only this much. Your brain cannot absorb so fast. Okay, that is that. Go with your abilities and don't try to put yourself too much of stress. Learn happily. Learn happily. But the thing is one thing, you will find out in a day time management, where do you waste? Where do you waste? One important thing I can tell you now, I told you beginning itself, whatever you do at night before sleep, whatever you do, next day morning when you wake up, you get the solution. Because whatever you see, that your brain thinks while you are sleeping. So that way, as much C programming, do it at the late evening and go and sleep. That is going to give you a lot of money tomorrow. Okay. Anything. I took a small opportunity because I don't want to take today's SPI or I2C. I've given up buses. I don't take today's SPI unless otherwise I explained to you that buses I cannot take them into the beyond UART. I explained what is UART, but UART has to be compared with SPI and I2C. Then only you will remember it. If it takes UART alone is waste. Otherwise, you have to spend another lot of time to work on it. That you will do that. You will do working on it. But these things, I'll compare it out, then you will know that what it is. So I've given a broad idea about how to prepare for the future. I'll keep on giving you. I'll keep on giving you that whatever I know. Ultimately, my job is to, you have to land on a very good job. You have come to me, we discuss. And I'm in the industry. I know that how the industry is looking for. And if you don't land on a good industry, good job, I'm very clear. I will always fight for, I will try to fight for everybody to bring 1 lakh a month salary. That's what I wanted. Is 1 lakh a month. That is what per month. This will be very easy way. This will be very easy way. It will be very easy way. It's not tough. It's an easy way. Okay, then any other thing? You have to become always top of the table. If you take VLSI, you should be the number 1 in the world. If you take embedded, take the number 1 in the world. They'll be always wanted. You go to the Premier, you go there, keep on going. See today, oh, I know C programming. I am above than this much percentage of EC people. Then I know about microcontroller programming. I know I am above than this many people. And I know about buses, spy, I2C, everything. I'm above this number of people. Then if I know about other things, PCI, PCI, I go thing. I know about ATAS. See that? That's why where you go, that indirectly you are pushing the other people below. You go up. Now, when the company will take a job, they will come here. They will try to take these people, but they will demand high salary. This case will go into the top of the companies. They don't. Okay, then they come here. Then they come here. So that's the way they come. If you say that, if you get in these companies so easily, never settle down. Go there. Don't try for here. You should try for that. If you are finding it difficult here, okay, then work on the space and integrate it. If you find it on working on here, if you say that you attend about 2 companies of here, they given you offer, then never go there. Go to the other company. Then that means that you are fitting here, not here. How can somebody will give you so job? You should lose 1 or 2 interviews and get the job. That's why we do most of that. Oh, this company giving me a job of per annum about 6 lakhs or 7 lakhs. I settle here. Okay, because that's the way we wanted, man. Fine. That job is there. Yeah, once you know that this job is there with you always, never worry. That if one company selected you for 6 lakhs, you will get a job in other company also. Okay, but try on this company who will try to give you 10 or 12, 8 or 10 lakhs. If somebody give you 8 of 10 lakhs, then go for here. 10 or 2. This will be of 24 lakhs or not, the top one. 24, 36 lakhs. Maybe very top, maybe very few. Getting about more than that. But I'm talking about 24 lakhs is a very good amount. That if you try for entire 4 years of ECE, well planned ECE 4 years, you have one small group, 2-3 people. Not one guy is not sufficient. 2-3 people work together as a friends from the first year to last year. You will get a 24 lakhs per month, man. What else you want? That's wonderful. You will be within about a few years. You will retire and do anything, man. But you don't do this. This you don't do. You cannot do because you will be having tons of assignments, tons of exams, and tons of work. It's not non-focused works. Basically, shall I tell you one thing? Let me be very honest. I'll record it here itself. Basically, if you remove M1, M2, M3, M4 in the colleges, you all will get a good job, man. Let me be honest. These things are only to be elective subject. Whoever wants, they should take. If I'm going to go DSP, I will take it. If I go on embedded, I did not have to take this. Why should I? Embedded engineers don't need to know these things. And that's science, engineering, and technology. When I go in technology line, I don't need that. When I'm going on engineering, I need it. When I go on science, I need most. Little. Very, very little. That's the trick. Okay, so I think we can wind up today. Because Friday evening, we will be taking a nice weekend off. Any other things, let me know. Otherwise, we'll wind up.